break problem number 3 into 2 separate triangles and then use the SAS area conjecture on both of those. We aren't going to break the triangles this way, because if I look at this triangle, I would know a side length and a side length, but I would not know the angle in between. I would not have enough information to use the SAS area conjecture. So we have to break the triangles this way. So this triangle, its area can be found with 1/2 the 2 side lengths multiplied together, multiplied by the sine of the angle between them. This triangle is also 1/2 the 2 side lengths multiplied by the sine of the angle between. Find the answers and then add them together. Do not round your answer until you have found both areas. So your very last step should be rounding, not before. We will use the SAS area conjecture 6 times to find the area of the regular hexagon. Well, not really. We will multiply 1/2 SAS, or multiply 1/2 the side lengths times the sine of the angle in between times 6. Now, one thing you'll notice about these triangles right here is that if you take 360 degrees and divide by 6, you'll end up with 60 degrees. So I know that each of these little angles is 60. I also know that because this is a regular hexagon, I know that these are all congruent as well. And because it's an isosceles triangle, I know that these two have to be congruent to each other. If I take 180 and subtract the 60 degrees from this angle, that leaves me with 120. I divide that by 2 because the base angles of an isosceles triangle are congruent. I also end up with 60. So this is an equilateral triangle, meaning that in my formula, I will take A to be the same exact length as B, that will be 5, times the sine of the angle in between, and the angle in between is 60 degrees. Multiply that into your calculator, you've got your answer.